Today we'll show you the scientific perspective of making a classic breakfast. Pancakes!
Hi, before we get started, we want to clarify the meaning of baking. Baking is a process of gluten activating. When gluten and gliadin present in flour are mixed with a liquid. The activated gluten, once combined with leavening agents, help the dough or batter expand. Finally, it is the thanks to gelatinization that makes baked goods end up in a solid form.
We're making 2 sets of pancakes using Aunt Jemima's Buttermilk Complete Pancake and Waffle Milk. For the first set, we are going to stir the batter until the large lumps disappear.
Now we're going to gather our ingredients and tools. Aunt Jemima Buttermilk Complete Pancake and Waffle Mix, 3/4 cups of water, bowls for mixtures, a fork to stir, tablespoon of corn oil, and an aluminum frying pan. We're going to use the food thermometer to check if the pan has reached the temperature. So in order to reach the temperature from room temperature to 375 degrees Fahrenheit, we're inserting around 177,059.52 joules.
Hey, why does batter have to be at a certain temperature to bake?
Well, at 375 degrees Fahrenheit, the mix is undergoing chemical and physical changes in order to turn into a pancake. As the temperature increases, the chemical leaveners are stimulated to a further extent, which causes the batter to rise. As fats are being melted, gases are being released because the water reaches its boiling point. Therefore, the pancake won't result in a stiff texture. Heat is also very essential to kill pathogens and harmful bacteria in the food. At 375 degrees Fahrenheit, enzymes in the batter are shut off by the heat, and that prevents that from consuming the batter.
Or else we will be left with a disintegrated pancake. Enzymes no swiping.
Snatchies!
If we cook the pancake batter at a lower temperature, the pancakes will not be fluffy. It will be somewhat liquidy, and the pancake would be pale, not golden brown as we like it, and it will be somewhat safe to eat.
I already filled 2 cups with pancake mix and 3/4 measuring cups with water. We're going to add water slowly to the mixture and stir with a fork until there are no lumps. Be careful not to overmix the batter for long. Afterwards, wait for 1 or 2 minutes for the batter to thicken. As you can see, we have created a homogeneous mixture or a solution because the mixture dissolved into the water.
Now we're going to add 1 tablespoon of corn oil into the frying pan. Wait until the oil sizzles and is spread out throughout the pan. Then pour around 1/4 cup of the batter for each pancake. As the batter is being heated, the particles are gaining kinetic energy and therefore moving faster. Some of you may be wondering, does the material of the pan have any effect on the baking process? My dear viewers, yes indeed. Thermal conductivity is a measure of how quickly heat moves throughout the pan. Aluminum pans have a thermal conductivity of 120 to 180 watts per Kelvin per meter. Also, due to the aluminum's low specific heat, which is 897 joules per kilograms per Kelvin, the pan has a faster heat transfer.
What specific heat?
So specific heat is how much energy is needed to raise 1 gram of a specific substance to 1 degree Celsius. If you use a different type of pan, like cast iron pans, there will be a slower heat transfer because the heat isn't distributed as quickly in copper than in aluminum pans.
Hey guys, I'm confused. Why doesn't the batter vaporize if it's being heated? Why doesn't it behave like a typical liquid?
Got you, Nicole. Okay, the reason why the batter doesn't vaporize and instead becomes into a solid is due to chemical leavening agents and gelatinization. When glycine and gluten are mixed with water, gluten molecules bond together to form a chain that is able to trap air. So once gluten is combined with the chemical leavening agents, like sodium bicarbonate, gluten forms pores or air bubbles. This occurs because CO2 is being released from the chemical leaveners and the gluten is trapping the CO2. As the pancake mix is heated, the air bubbles expand, which causes the batter to rise. The solid structure of the pancake is due to gelatinization, because the starch in this batter absorbs a lot of water, making the batter be more thick and have more viscosity. Therefore, instead of the batter boiling and evaporating like a normal liquid would under these circumstances, it forms into a solid. Voila! We have pancakes! Thank you, science!
Once the pancakes begin to bubble and the bottoms are golden brown, use a spatula to flip them over. Repeat the steps until you finish the entire batter. So guys, how would a recipe change if we were in Denver, Colorado? Well, to start, Denver is at a higher altitude as it is above sea level. That means there's a lower air pressure and less oxygen, making methods of baking harder to complete. Therefore, people make adjustments to their own recipes.
In the case of pancakes, making them at a higher altitude means that they rise higher in a short amount of time. However, this also means that they would lose moisture quicker as water is being transformed into vapor at a faster rate. Due to this, bakers lower their cooking times to make the temperature and timing changes.
Ooh, these pancakes look so delicious and they look so fluffy.
Splendido.
Thank you for joining us in this awesome scientific journey of making pancakes. See you all next time. Bye!